So I think I gave this formula gamma p by rho last time. Na? That was for a longitudinal wave by rho, and this gamma was the correction factor. This gamma is actually Cp by Cv. And this formula can equally be written as something like this: gamma RT by M. I forgot to write this formula. Where what is R? What is R?
Ideal gas constant.
That's a gas constant. And what is the gas constant value? 8.314. That's the exact value. And units? Units याद नहीं है.
Into 10 power 7 hertz.
10 power 7 भी आ गया. अरे तुमने क्या है केमिस्ट्री में क्या पढ़ा था? आज तुमने थर्मोडायनामिक्स फिजिक्स में पढ़ा है, केमिस्ट्री में पढ़ा है ना? Joule mole inverse.
Kelvin inverse.
This is correct. And what is this capital M called? That's the molar mass. And what is this T? The absolute temperature. What is this measured in? Kelvins. Good. So I talked about these formulas, and then I also talked about V is equal to under root Y by rho. Where what was Y? Young's modulus, right? And that was for a longitudinal wave passing through a rope. So for longitudinal wave, passing through rope or spring, the formula was V was equal to under root Y by rho, where rho was the density of the medium and Y is a Young's modulus of this rope or spring, whatever. I think I have written these things last time. And then I gave one question. Anybody attempted that question? So I'm just directly starting with the question. The question was something like, the setup was this, that there is a support here, a pulley, mass M, that was something like 5 kg I think. And then there is a thing, this is, and then this was A. क्या बोला? Moving through the rope or anything. That wave is moving through the rope, ना? ठीक है, passing through the rope. So, now I asked you to find the, you are giving a transverse blow here, somewhere here, at one end, and then they are asking to find the time taken for the pulse to reach the other end. When I say the other end, am I talking about B or am I talking about mass M? What do you think? Read the question. The end of what? Where do I hit? I'm hitting the end of the rubber tube, na? Then the other end being the end of the other end of the same tube or not?
So this is not the diagram.
Not.
Sir, we gave it as
Where the different person end?
No, it's like this. It's like that. I made a wrong diagram maybe last time. This was the string and then there was a rubber tube. A rubber tube is mentioned in the question, no? It's not mentioned.
No.
What was the question that I gave you?
One
One
minus
plus
one.
Cut the question. Instead of cutting the whole question, write the one end of a rubber tube. So let me write the question, right? Then देखा तो मैं गलती कैसे कर दी? Let me write the question again. One end of 1 meter long rubber tube I will try to give sheets from next lecture onwards. I'm sick of writing the whole question on the board. इतना लंबे लंबे क्वेश्चन भी है. So then, let me give you 3 minutes. I think you should be able to do it now. The handwriting is readable, na? I got some comments on my handwriting today. Just to be sure. Isn't it beautiful? Yes, good. What do you think? ये क्या है इधर?
स्विमिंग पूल
कौन था ये जो कंट्रोल नहीं कर पा रहा था? गोविंद?
This is Aditya sir.
दोनों एक साथ में? सी बाबा।
सर मैंने आने से पहले था सर.
नीचे वॉशरूम्स बने हैं क्या? So I will wait till 12:11, then I will start. Giving you 2 minutes. Let's start. Student 11. Anybody with any answers? Wait, one more minute. It's not that hard. Don't worry. Should I start then? I think I have given you plenty of time. It's given that you have this kind of rubber tube which is attached to one end of the string. That string is attached to a mass M. And this A part is attached to this base part. Now they are asking to find, let's apply some kind of transverse globe here at point A. Then they are asking to find what is the time taken for the pulse to reach the other end. And when I say other end, am I talking about the mass or B? Talking about the other end of the rubber tube itself. So B. Yes? So they are asking about the time taken. So speed equal to distance over time, time is equal to distance over speed. So distance is already mentioned, I have to find the speed of the pulse. But what will be the speed of the pulse? What kind of flow it is? So what kind of wave it will generate? Transverse wave. So what is the velocity of a transverse wave through a rope? V is equal to under root T by mu. But can you tell me what is the tension in the string? That's 50 Newton. Everybody understands that's mg. Mg of the mass, and that will be 5 into 10 isn't it? Mu है mass upon unit length. So mass इसका mass और इसका mass?
0.
The other one, na? Rubber. So what is that mass? 0.9 divided by 12. Now can somebody do this calculation? 0.9 है. अभी 3 के टेबल से I think कट रहा है. 3 3s और 3 4s का. ये पॉइंट ऊपर गया 5500 हो गया 500 into 4 2000 divided by 3 and this is approximately root 667. अब which root is the closest root? 25 करो स्क्वायर कितना होता है?
676.
625 होता है और 26 का स्क्वायर
676.
So which is the closer one? 26 but 25 point actual कुछ होएगा ना? Let's assume 25.7. Is it good enough? 25.7. 25.7 meter per second. That's my V. Then they are asking to find the time taken. And time taken is distance upon velocity. So what is the distance it has to cover? 12 divided by 25.7. ये भी कुछ I think 12 ones are 12 twos are 24 और इसके बाद 1 बचा 17 12 ones are 7 12 ones are 12 5 बचा 12 fours are 48 कितना जा रहा है अप्रॉक्सीमेटली जा रहा है 2.14 चेक करो जरा अच्छा 2.14 को 2 अगर मान लूंगा तो 1 by 2 0.5 so something a little less than 0.5 something like 0.48
हाँ
4847 ऐसा कुछ चेक करना हम लोग 0.48 मान लेता हूँ या फिर 47 चलो कैलकुलेशन करके चेक कर लेना ठीक है Is it okay? This was our question. Now these are all simple questions. Let's try to do something. Can I give one question as a homework? A related question, exactly same, just a little modification. Can I write it? So it's written till here. The diagram is something like this.
Suspended from series.
These things are given. Take it as a whole. As you can see, it will be again very simple. What will be the only difference in this question? Can you already guess what will be the only difference? Tensions. The tensions in each string. Otherwise, views are already given to you. So it will be a piece of cake. And I think I have given you a very complicated system in strings. You can easily find such a tension in a simple system. Then let's go to the last topic of the chapter. And then we will do problems and that will be the end of it. And that is the energy of wave motion. Can I go forward? For those who have any completed the revision of 11th and everything, there's a very good book that I found. You can go over the questions that are done in that, even the solved examples. It's Rahul Sardana. And all the books of it, even the optics part, the questions are very, very good in that. So you can maybe download the e-book. You can go to there's a website. If I say it here, to copyright लगेगा क्या? I don't know. There's this website called JE Archive. In there you can find this book. बहुत अच्छी book है, very good. So you will find all the volumes of all the things in 11th and 12th standard. There are very, very nice problems on even the solved problems and unsolved problems. Yeah. Good. For those who were present on the last online study hour that I did, the questions that I gave was from this book. Okay. Anyways, so let's go to the last topic of this chapter. Energy of variation. A common practice that we do when we try to imitate a medium or any kind of system is we often try to do this. You remember that when I was talking about tensions and normal forces, these things last time in 11th standard, I talked about electromagnetic forces, and then there was interatomic or intermolecular forces of attraction. You do something here, the other particle gets affected. Yeah. So how does a wave move in this medium? You can imagine it like this. All the particles in the medium can be thought of as small masses which are attached to each other by some springs constant, springs of some spring constant K. You can imagine such a setup. It's obviously not there. There is no spring between two particles. But you can imagine that all of them are connected to each other by the spring. And anything that occurs, if this particle starts oscillating, then there will be some kind of effect on that, and then this will be giving the effect to the other particle, and so on. It keeps on occurring. Now, how will it start oscillating? Maybe a disturbance enters the medium. From where the disturbance comes? A source S. The source of disturbance. As this disturbance enters the medium, it oscillates this particle. This particle oscillates with some angular frequency omega, and it has some energy. And then, since it is connected to us by a spring, this energy gets transferred. Transferred, it oscillates, then it transfers the energy again, and this keeps on occurring. And the wave moves with it as the energy moves, and this is how a wave carries energy from one point of medium to another point of medium. Please remember that all the discussions that I have been doing is for mechanical waves. So this idea only applies for mechanical waves. What is the idea? A disturbance enters, oscillates a particle, gives it off some energy. This particle gives off energy to this particle via the spring, and then it keeps on occurring, and this is how the wave carries energy. Then there can be a maximum or the total energy of the system of such an oscillator. Then do you remember the expression of total energy of a harmonic oscillator? So
half half k square minus half k square.
that's kinetic energy.
half k
Half
x
k
square minus
X square minus x square.
half k
Half
x
k
square.
square is for potential energy, and then kinetic energy is half k a square minus x square. Then total
Half k
energy is half k a square.
Yes.
And k can be written as m omega square, na?
Yes.
Then the energy, total energy of an oscillator. So for a source giving or emitting, remember that I can only approximate a particle to perform SHM only when the source is giving of a sinusoidal wave, not for all kinds of wave. Maybe you can have a wave function which is e to the power something. That will not result in a particle performing SHL. That may be some other type of oscillation, but not SHL then. So SHM is very special only to a sinusoidal wave. So for source emitting sinusoidal wave, the particles of medium performs SHL. Then what is the total energy of the particle? Total energy of each oscillator is, that's capital E, that's half m omega square a square, na? Is it correct? Where what is the m? There's the mass of each particle. M is mass. What is omega? There's the natural frequency of each particle. What is A? Amplitude of oscillation. Everyone knows this? Then instead of talking about the total energy, we like to talk about something else. That's called the energy density. Then do you remember how we define mass density? Mass density is mass by volume. Number density is number by volume. Then what will be energy density? Energy by volume. And what will that be? So energy density, that's U, is total energy divided by volume V. Okay? Volume. Please don't get confused between my capital V and my small v. Small v is for velocity. So I should make this capital V. This is half m omega square a square divided by volume. Then mass by volume is what? Density. That's mass density. So your energy density is equal to half rho omega square e square. Where what is rho? It's the density of the medium. Is it okay? Density of the medium. This is the expression of energy density. U, small u. I know that, but still, anything that happens in this particle gets affected to this particle. If you remember, this particle influences the other particle by some force, some interval. This force can be written as minus dV by dx, du by dx, where u is the potential, some kind of potential. That potential, what we find in systems, that potential can be approximated to the potential of this spring mass system or a harmonic oscillator. Every time, this is why harmonic oscillators are so important in nature. Everything in nature can be approximated to an oscillator. Everything. Most of the things that you find, everything is potential. When I say approximated, basically I am talking about the interactions, the potential energy can be approximated to the potential energy of harmonic oscillator. This is what we find in nature. Obviously, it's not the exact description, but it's approximately true. Good. Now, this is the energy of wave motion. Let's talk about the. Asha, I talked about the energy of each oscillator. Please remember. And then, what will be the power delivered by each oscillator? The power. And what was the formula of power? Energy transferred in 1 second. That's power. Energy transferred in 1 second, or energy given off by unit time, basically. So what is the energy? Acha, if energy density is energy by volume, then energy is density into volume.
Yes.
Then I can write it like power is U times. And let's try to make a diagram before getting into this. let's say this is my y, this is my x, and I'm not fixing time or anything. I have a wave like this, and this wave travels from this point to this point in 1 second, m to n in 1 second. And let's say the speed of the wave is v. Then what is the distance mm? Speed of wave is v. You travel for 1 second. How much distance do you cover? V distance?
V distance.
Yes. Speed equal to distance over time. Distance equal to speed into time. In 1 second you travel v distance. And can you imagine the wave has traveled that distance? So, ये picture देख रहे हो? ये picture ऐसा कुछ आएगा. This point has moved to this point. Yes? You're tracking one point. So how much distance do you cover? Let's say the wave is actually this is a transverse wave, no, my dear?
Yes.
I'm doing the discussion on transverse wave. This can be thought of as a wave going through a rope. Transverse wave traveling in a rope. On a rope. So, what is the length distance covered? In 1 second, that's v. That's v. What is the area of cross section of this rope? Let's call it S. Okay? Area, cross sectional area. Equal to S. Then what is the volume? The volume of the medium. ये medium मेरा rope ही है ना? Because the wave is traveling through the rope, na? Then what is the volume of this thing? Going from M to M?
Yes.
That will be Vs. Yes or no? So volume is equal to S times V. Then what was energy? Energy transferred is E is equal to U into
Yes.
U into volume, and that will be.
USB.
Is it okay? Then what is the formula of power in 1 second? Then power is equal to U S V upon 1 second. And what will that be? Batao. USB U is what? Half m, half rho omega square a square s v. This is the power. Where what is v? That's the velocity of the wave. Please don't forget. And s is the cross sectional area. Is it okay? Everyone has written up till here? This is the power delivered, or the energy transferred in 1 second by one oscillator to other oscillator. Please remember, even though I took a very special example of a transverse wave traveling through a rope, the formula applies even for a longitudinal wave, to any wave. Applies to any kind of wave. This is power. Let's talk about the final quantity. It's called the intensity. Can I write it? चलो जल्दी जल्दी हाथ चलाओ, वरना it will take 2.5 years to complete the syllabus. Can I go forward?
Yes.
How is intensity defined? How is intensity defined? That's power upon area. Power delivered per unit area, that's intensity. Power delivered what should be it should be P by S, where S is the cross section. I'm not writing A because A I have already used for amplitude. So what is this power? Power कितना था ये? तो S S can't do directly the formula. Half rho omega square A square B. Simple stuff. Just remember the formulas. I just want to write one note and then we will be off to problems. So, am I going too fast by the way? Should I wait a little bit? It's okay? Great. Note. The note is, what if you have a source which is emitting the waves in all possible directions? Achha, I should also write this, see all the formulas. Formula discussed above are applicable to longitudinal waves. Longitudinal waves as well. Okay, longitudinal waves as well. And the note is, what if you have a source which is giving off source S, which is giving off the waves in all possible directions, then what will be the intensity? Acha, this, if I consider the locus of all these points, then what will it make? Circle. Should be sphere, right? All possible directions. This is a sphere, imaginary sphere. What is the source? The source S is emitting waves in all possible directions. Then what will be the surface area of the sphere?
4 by 3 by
4 by R square.
4 pi r square. So your intensity will be power by 4 pi r square, and then your intensity will be inversely proportional to r square. No? Yes? Just remember the result. With this we are done with the theory part of this chapter. Now we will go to application side. So if it is done, then tell me, let me write some questions. And definitely from next lecture onwards, I will give you a sheet. I am sick of writing the questions. Do you like it like this, or the sheets are better? Sheets better, huh? ये क्या बना है साहब? नहीं बेटा ये बच्चे ऐसे स्फीयर ऐसा बनाते हैं कि ऐसा बना होगा अंडा। ठीक नहीं है बेटा, मेरे जैसा स्फीयर है ना, एक परफेक्ट स्फीयर। Can you see it? It's a 3D representation. Can you see that? So can I go forward then? Let me write the question. ये तो बहुत simple सा question है. Just a little calculation. Just a little calculation करिए. let me be clear with this, that unless it is specifically mentioned that the density is linear mass density, then you will not give the given density to be mu. You will not assume that. If the given density is just written as mass density, then what you will assume it to be? That's rho, mass by volume, not linear mass density, unless it is specifically mentioned. ठीक है? Let me give you 4 minutes to think about it, then I will start. 12:47. It's 12:47. Should I start? Did he get the speed of the wave? Anybody with the speed of the wave? Calculation heavy है करो. Should I start myself? Let me start with it. It's given that it is going to be a transverse wave. Now they are asking to find the equation of wave. Then what was the equation of wave? Achha, there is so many information I should write on it. Everything given. What is given? Diameter is going to be 4 millimeter.
Yes.
Frequency 10 hertz. Tension 100 Newton and
Mass density.
it's given to be the mass density. This is not linear mass density, no?
Yeah.
So rho is given to be this way. For the A part, they are asking to find the equation of the wave, but that is given to be y is equal to a sine kx minus omega t. Na? This is how we write the wave, the sinusoidal wave. Yes. What are the things that I have to find here? A, I have to put, A is already given. I have to find this k and this omega. But k के लिए I need to find lambda and omega के लिए f. But f is also given, so omega is also done. I have to find lambda. But v equal to f lambda, that means I have to find v. If I find my speed of the wave, then I can find my lambda. Yes? But then, do you have an expression for speed of wave?
A by under root
E
T
by
by
mu.
mu.
But now understand, should I substitute rho with mu?
No.
No. I should write this. Mu is what? Mass upon length.
Yes.
Let's multiply and divide by area. Then this will be mass into surface over surface into. Then what is surface area into length?
Volume.
That's volume. So you'll get mass into S upon volume. And what is mass upon volume? That's rho. So what is mu? That's rho S. So I should write here root P by rho S. And what is the cross sectional area of wire? Cross sectional area of a wire? बताओ क्या होगा? अरे यार क्या है ये? सर्कल का क्या होता है एरिया? बोलो ना मुझे ऐसे। क्रॉस सेक्शनल का मतलब नहीं पता क्या? You don't know? Cut it. Then what is the tension given to be? 100 और rho कितना है? 4.2 10 to the power 3 and then S कितना है? pi r कितना है?
2
That's 2 millimeter ना?
Millimeter.
2 square 10 to the power minus 3 का square. ये denominator का सारा calculation करके हो तो I can do one process but that will be very long. ये I found in other class Vajrapur did it कि ऐसा कुछ तो denominator 168 pi आ रहा है. ये करो जरा denominator.
Yes sir, 160.
168 आ रहा है. ऊपर 100
Yes.
और उसके बाद 100 का रूट होता है 10 ना?
10 by 13.
10 by ये वाली कितने आ रही है?
12.9.
12.9?
169 is 30.
नहीं, there's a pi as well ना? 168 times 3 approximately 3 तो 170 times 3 कितना हो गया? 70 times 3 is 500 बचा रहा है. ये exact value बताओ जरा.
504 it.
504.
Root means
504 से थोड़ा ज़्यादा नहीं है क्या? ठीक है कोई बात नहीं. Which is the closest root to 504? 20 का कितना होता है?
400.
22 का?
484.
4.
22.
23 का? 529. 520.
Yes sir, 529.
529. क्या करें? तो 22.5 के अप्रोक्सीमेटली बीच में आ गया ना भैया. तो 22.5 ले लेते हैं. तो 10 divided by 22.5. ये तो सही नहीं आ रहा है.
Sir, it's not 504.
कितना आ रहा है?
163.
बताओ सर. ये डिनोमिनेटर 168 पर ऊपर 10 to the power कुछ जाना चाहिए क्या?
Maybe it's
100
10
power
power
three
minus 1.
10 by 3 will go up.
10 power 3 will go up ना. So this will be 10 to the power 3 ऊपर. और वो 10. So this will be 100 root 10. ये चेक करो प्लीज क्या हो रहा है. डिनोमिनेटर 168 पाई ले. पावर 3 ऊपर लेना है क्या? मुझे खुद ही करना पड़ेगा.
16.8 आएगा into 10. No, 1680.
So your 10 part 2 will go up, sir. If you are taking 168 by 10 part 2 will go up.
अच्छा. पक्का है ना?
Yes sir.
ये अब सही है. मुझे अभी भी कुछ तो गलती लग रही है.
Sir, if you take pi 3.14, then it will come 521.52. So 521.
नहीं, यहाँ से यहाँ के स्टेप में बताओ ये सही है क्या? मैं तो
Yes, sir.
मैं दूसरे यूज करता हूँ.
Correct.
516.
516 है.
Something.
देखो हम लोग को वैल्यू आखिर की आनी चाहिए 44 के अप्रॉक्स.
16.8
क्या बोल रहा है?
16.8 into 10.3 is
और ये
2.2.
16.8 10 पावर 3 तो 168 10 पावर 2 ऊपर गया. सही बोल रहा. तो ये 10 पावर 4 का रूट 10 पावर 2 डिवाइड बाय रूट 504. हाँ रूट 504 बताओ कितना हो रहा है? बोलो बोलो. 23.
Yes, sir.
You tell me. I don't know. You tell me. What should I write 23?
Sir, it's not 504, sir. It is
520.
527.5. 27.5.
Oh, 527.
528.
हाँ
528. ये मुझे 10 का फैक्टर नहीं गायब हो रहा है यार। ये 1000 होना चाहिए ऊपर, 100 नहीं होना चाहिए। 1000 होगा तो शायद से करेक्ट कर जाएगा। चलो मैं अपने प्रोसेस, तुम लोग अपना करना, मैं कुछ करता हूँ।
22.6 वही सेम ये सेम
Let's take this 10 power 3 above. So 10 power 2, 10 power 3. अब ये 4.2, 3.14 and 4. I'm going to do a lot of approximations ना, ये मैं अभी अपने मर्जी से कर रहा हूँ, तुम लोग चेक करना कि क्या आता है आंसर। ठीक है, ये 10 पावर 5 हो गया, जो बेसिकली 10 पावर 2 डिवाइड बाय 10 ये ऐसा हो जाएगा कुछ।
Sir,
हाँ बोलो।
the density they gave in meters.
In what?
Nothing, sir.
सही, ये मेरे सब्स्टिट्यूशन भी सही किया ना, देखो। आंसर आ जाएगा तो हो जाता ना। 10 पावर 6 होगा। माइनस माइनस 3 का स्क्वायर हो, ऊपर के तो 10 पावर 3 हो गया। There's a 10 power 3, 10 power minus 3 cancels. There's a 10 power 3. Amplitude is? But amplitude is not. कहाँ इधर amplitude कहाँ से आ गया? क्या बोलना चाहते हैं इधर? There's no amplitude here. ठीक है। ये बताओ 4.2 into 4 कितना हो जाएगा? 16.8। 16.8 को 17 अप्रोक्सीमेट कर दिया। 17 को 3.1 से इसको 3.2 से मल्टीप्लाई करो। ठीक है? अब बताओ 3.2 कितना होता है? कितना हो रहा है? अच्छा ये भी छोड़ो, 17 रहने दो नीचे। अभी रूट वो रूट 10 ऊपर है ना, नीचे 17 into 3.14 है कि नहीं? अब इसको करेंगे ऐसा, नहीं बताओ इसका कितना है? 3.2 मान लिया,
3.1 लेकिन एक सर और 3.2
54.55
54
ये 55 मान लिया, और रूट 10 की वैल्यू कितनी अप्रोक्सीमेटली 3.2 55
रूट से
रूट भी है इसमें। अब बताओ और क्या कर सकते हैं?
3 मान लो सर।
रूट 10 को 3.2 मान दो, रूट 55 को क्या मान सकते हैं बताओ?
7.3 that is 7.3
7.23 कुछ बार नहीं, बाद में 7 ही मांगते हैं। इसको 7.3। अब बताओ इसका वैल्यू बताओ। ये सब बहुत कचरा का अप्रोक्सीमेशन करके कर रहा हूँ, बट बताओ आंसर बताओ।
22
चलो ये हो जाएगा अप्रोक्सीमेटली।
40.
अब बताओ इसका, हाँ 43 के आसपास ले आओ तो फिर मैं खुश हो जाऊंगा।
सर कौन सा?
अब 44 चल जाएगा। The actual
44.
answer is 43.5. So we are very close. So this is equal to 44 approximately meter per second. If you actually do it, then you will get something like 43.53 meter per second. That's the market approximation. Yeah. Very good. So we found the B. Now we can find the K, na? And we can find omega. What is B equal to lambda F? Then lambda equal to B by F. What is B? 44 मान लो. What is F? F कितना दिया है?
10.
10. इसको 4.4 हो गया? अच्छा चलो गया अच्छा वाली बात 4 4.35 अच्छी चीज मानते हैं ठीक है क्या होगा सही कर रहा हो कि नहीं yes good what is the equation y is equal to a sin ax minus omega t अब a कितना है -4 sin a 2 pi by lambda lambda कितना है 4.35 x minus omega कितना है 2 pi f
2 pi.
what is that
10.
25 t this is y ठीक है I found my y what is u they are asking u in the second part huh? What was the formula of u half rho omega square a square अब ये मल्टीप्लाई करके निकाल सकते हैं आपको कुछ कैलकुलेशन भी नहीं करना है करो तो जल्दी करो come on give me an answer for e हाँ
0.8
पावर कुछ है नहीं इंटर it's something like 8.3 into 10 to the power minus 2 तो तुम लोग का पावर -1 का है ये बोल रहे देखो अरे इतने सारी चीजें बाप रे मेहनत ही मेहनत वेरी गुड निकालो बेटा बैठना नहीं डोंट सिट आइडल कैलकुलेशंस करनी है बॉटल ये गिरी हुई बॉटल यही गिरती रहती ना बार-बार कि वो वाली सर दोनों गिरते दोनों गिरी हुई बॉटल है
so power is 0.43
incorrect very good it's 4.53 into 10 to the power minus 5 पावर्स में गायब हो गए बेटा पावर्स में गए
8.3 into 10 power minus 2
yes correct ठीक है so what is this this is 8.3 into 10 to the power minus 2 joules per meter square what about the power anybody got the power क्या था इसका फॉर्मूला
हाफ रो ओमेगा स्क्वायर ए स्क्वायर एस बी क्या
करते जाओ मल्टीप्लाई करते जाओ आराम से बैठा हुआ है
10 पावर माइनस
अच्छा लैडर गेम खेल रहे हैं where are you trying just wrote the formula ये श्रीनिवास जब तक आंसर नहीं देगा तब तक आगे नहीं बढ़ेगा अटेंशन रहे हो नहीं क्या है Rashes.
फोर बाई
बोलो ऋतिक मारेंगे तो रैशेस आते हैं क्या बच्चे इधर के इतने ज्यादा
फोर बाई
So 45 into 10 power minus 6 power.
करेक्ट है चल जाएगा have it. I was asking you to do this, not that. By the way, you can equally do this, huh?
U into S.
ये भी कर लो चल जाएगा. ठीक है?
Once can you scroll up?
Scroll up. You want to look at my beautiful approximation.
Yes.
हमारा आंसर आया है. कल आके मिला नहीं ना बेटा, कल भी बोला था. कितना भी बोलो बच्चों को कुछ फर्क ही नहीं पड़ता है. क्या फर्क है? This is incorrect. Correct. Precious है. चलते रहेंगे. ये तो एक बार. पुरानी दुश्मन नहीं है ये देख तो मेरे पास ये मजा नहीं है मैं कहता हूँ मार बॉम्ब फुटते रहते हैं आवाज करते रहते हैं. आगे बढ़ जाए. ग्रेट. तो क्या चीज 10 ही मिनट बाकी है क्या? मेरे को पढ़ाने का मन नहीं करता. चलो एक और क्वेश्चन करते हैं क्लास में.
रिविजन टाइम
43.5 तो यार
10 मिनट में क्या कर लेंगे? Let's do this one more
वेट
time.
कर सकते हैं इसमें क्या है.
और rather take it as a homework. Hey, don't talk. Okay, I'm not teaching anything more than this today. We'll try to do some problems in the next lecture. Some standard problems and then we will be done. Okay. In total 15 questions we will try to do. Okay. So we can stop the recording. But